Hello, this is Lorraine Jamison with GoReact exam number 1, and this is problem number 1. So in this problem, we were given a differential equation, and we had to solve for p of x, f of x, and the equation itself. So to begin, we have dy dx times the quantity of 1 plus x minus xy is equal to x plus x squared. So in order to find p of x and f of x, you need to put this equation into its standard form. So you just divide everything by 1 plus x to isolate the dy dx variable. And the resulting equation of that is dy dx minus x over 1 plus x, y is equal to x, because that cancels out. And then because 1 plus x is a denominator, x cannot be equal to -1. And so once this is in standard form, you can solve for, or you can find p of x and f of x. So p of x is equal to negative x over 1 plus x, and then f of x is just equal to x. In order to solve this, you find the integrating factor mu, and mu is equal to e to the integral of px. There should just be a dx here. So you just plug in that integral, so you get e to the ln x plus 1 minus x. And so you get x plus 1 times e to the negative x. Perfect. And so you plug this in to this equation right here. So mu times y d dx is equal to this integral. And so you take the integral of both sides. So you get x plus 1 e to the negative xy is equal to the integral of x e to the negative x plus x squared e to the negative x. It just distributed right there. And then you take the integral, because of integral properties, you can integrate this separately. So you have x plus 1 e to the negative xy is equal to negative x plus 1 e to the negative x plus negative x squared plus 2x plus 2 e to the negative x plus c. And then you just divide both sides by x plus 1 e to the negative x to get this final result. And then the interval of existence for this equation is -1 to infinity, because as stated above, x cannot equal 1, and the interval of existence is the largest interval with which it exists. So it's only asking for one side. I could have also used the integral -infinity to -1, not inclusive. And then here is problem number 2. I will preface this with I do not know if this is the right answer, but I will explain my thinking in my work anyways. So this problem, you were also solving it. So you have x squared minus y squared dx plus y squared minus 2yx dy is equal to 0. So the first task we were given was to prove that it was homogeneous to the degree of 2. So in order to do that, we just plug in t's and then simplify. So m of xy was t squared, so that means it's homogeneous to the degree of 2, and then n was tx, ty, and then you plug that in. So t squared is degree homogeneous to the degree of 2, and t squared is equal to t squared, so we can use this substitution. So then we were given our y is equal to ux, and hence that means dy is equal to u dx plus x du. So basically you plug in this ux anywhere where you see a y. I did thus. This all equals 0 on the end, by the way. So you just plug that in and you distribute, and then you combine like terms. So for instance, this u squared x squared dx combined with the u squared x squared dx to form this. And so ultimately, you end up with x squared, 1 minus u squared plus u cubed dx is equal to ux that's cubed times the quantity of 2 minus u du. And so I divided both sides by x squared 2 minus u, x squared 2 minus u to simplify these equations. So ultimately you get 1 minus u squared plus u cubed over 2 minus u dx, and then ux du. And basically you take the integral of both of these. You can treat this as a constant because we're integrating an x, so you just, yeah, that's that. And then u squared x over 2 plus c. And then after that, you can plug in your u is equal to y over x. And so I just plugged in y over x, and then I subtracted this value to the other side, such that c could be by itself. And so this was the final answer, which is x times the quantity of 1 minus 3 times y over x squared plus y over x cubed all over 2 minus y over x minus y over x squared x over 2 is equal to c. Thank you.